This one, we're trying to find the longest side. So are we going to be adding the squares or subtracting? We'll be adding, right. So you're going to go 15 squared plus 21 squared equals x squared. So 15 squared, what is that? Like 225 or something? And 21 squared. Together they make, ooh, not a great number. 666. So we're going to do a square root of that. And you should get 25.8. Yes? Oh, is it 2 decimals? Round to 2 decimal places. There you go. 25.81. Good. Okay, this one, again, you're adding. So you're going to go 8 squared plus 19 squared, and then you're going to square root the whole thing. That's how I could write it all as one step if I want. That's what it would look like as a math expression. 8 squared plus 19 squared, and then put a big square root over it. Then I could just do it all as once. So if I wanted to do it in one step here, I could put in my square root. I'll put a bracket, and I can do 8 squared plus 19 squared equals 20.62. Okay. Then the next one, x is going to be the positive square root of 40 squared plus 30 squared. And should work out to exactly 50, right? Yeah. Really, this is just a 3, 4, 5 triangle, and they just multiply each side by 10, basically. Okay. If this was 300 and this was 400, what would x be? If this was 300 and that was 400, what would x be? 500, yeah, exactly. Okay, now this one is different. Notice that we're looking for one of the short sides. Am I still doing addition? No, so this time I need to subtract, right? And you're always going to be subtracting from the large side squared first. So as one step, so I would go 4.3 squared minus 2.9 squared equals x squared. So 4.3 squared minus 2.9 squared, which is 10.08. So, and that's the square. So now I need to square root that. And I get 3.17, right? Did you get 3.17? Yeah? Okay. Okay, this one, same thing. This time I'm looking for the square root of 92 squared minus 68 squared. So you get 61.97 for x. Okay, that's over there. Okay, this one, it's going to be the square root of 6 squared minus 3.8 squared. I know what 6 squared is. I can just write 36. I don't know what 3.8 squared is, so I'll have to punch that in. And I got 4.64. Yes? Okay. This one, I'm looking for the long side, so it goes back to addition. So that's the square root of 17 squared plus 21 squared. So x becomes 27.02. And this one would be the square root of 21 squared plus 16 squared. Okay, square root, bracket, 21 squared plus 16, oops. And I got 26.40. Yes? Yeah?
Yes.
Okay. And this one would be the square root of 2 squared plus 90. Oh, oops. Look at here. So this one I'm going to put an asterisk by it because the units are different. This one's meters and this one's centimeters. So I can't do that unless I change them to the same. It's probably easier to leave the 94.3 as is and change 2 meters. How many centimeters are in a meter? Yeah, cent means 100. So there's 200 centimeters there. Yeah, so this becomes 200 centimeters. So that's what I need to use here. 200 squared plus 94.3 squared. Okay. So yeah, that was tricky there. Different units, you got to convert. Okay, so that is 200 squared plus 94.3 squared, and then square root it. So I got 221.12 centimeters, or you could put that as a meters answer, which would be, I guess, 2.21 meters. Oh, sorry. That's the long side. It's minus. I mean, I meant to do that to see if you were watching closely. Unfortunately, you were. If you weren't watching and you were just blindly copying down my stuff here, you're going to have a mess. And just to demonstrate how messy your paper will look if you were copying me, that's what it would look like. Okay, so 200 squared minus 94.3 squared equals, did you get 176.37?
Yes.
Okay, 176.37. Or in meters, that would be 1.76 meters. So you could have left the 2 and changed this to like 0.943 meters. It would have given you that. Either way is fine. All right. Okay, it seems like, how many of you caught that conversion thing there? First time you noticed it? Yeah, did you notice right away? Yeah. So that's why I always try to pay attention to the units. Probably what most people would have done, they would have looked at the back, got the wrong answer, and said, what? And went back and said, oh, okay, there it is. Okay, word problems. Number 2. A computer is on sale, aren't they always? And is listed as being 21 inches. That is a diagonal distance across the screen. Yeah. By default, if you look at computer monitors or TVs and they say it's a 55-inch TV, they mean diagonally. Okay. If the computer is 10 inches in height, well, it's a computer monitor. What is the width of the screen? Okay, so they basically want to know what this is. There's your X. 21's there. So you have the long side. You have one of the short sides, and you want to know what the other short side is. Okay? And when I look at a diagram like that, I usually will make a prediction. Looking at this, I would assume that the answer I get is bigger than 10, but it's definitely smaller than 21. So if I get any answer that's between 21 and 10, I'm going to feel pretty good about it when I do it. Okay? So I'm just going to do, so X is going to be the square root of 21 squared minus 10 squared. Okay, and if you're doing it all in one step, use brackets. Or if you want to be even more formal, parentheses. if you like saying the word parentheses. If you don't, we use the round bracket. 21 squared minus, well, 10 squared is 100, so it's approximately 18.47 inches wide. Is that what you got? Okay. And it's between 10 and 21, so I feel good about that. I'm assuming it's correct. Oh, answer to the nearest inch. So 18.47, am I going to go up or down? It's below 50, so you have to drop it. So round it off, you'd say 18 inches wide. Round it off. Yeah. Good. Number 3, 2 joggers run 6 miles north and 2 miles east. It's an 8-mile jog. Is that a short jog or a long jog? That's long. Yeah, that's long jogging. 8 miles. Like a really fast runner runs around maybe 6 minutes a mile. So that'd be like an hour for joggers. That's like an hour of jogging. That's a lot. Okay. So to draw this, north is straight up, right? So I'll put a 6 there. Then 2 miles east is to the right, right? So this is east. So I'll put a 2 there. What is the shortest distance they must travel to return to the starting point? Okay, so they're going to take they're not going to retrace their route, they're going to go straight back. So what that means is they're going to come back this way, right? So that's your triangle. They went 6 this way and 2 that way. How far do they have to go if they go straight back? Right? Assuming they can, they're not running through the woods or something. So that's my x. It's the long side, so am I adding or subtracting? I'm adding. So x is going to be the square root of 6 squared plus 2 squared. That's going to be the square root of 40. So 6.32, because it's at 2 decimal places, and those were miles, right? Okay, 6.32 miles. Is that what you got? Anybody get anything different? It's okay? Okay. Number 4, Julie made a rectangular table for her dining room. All right, so I'm going to draw a rectangle. I made a rectangular table a couple years ago. My wife wanted patio furniture. Have you ever looked at the price on patio furniture? It's like hundreds and hundreds of dollars. And she wanted a table. I looked at the prices, I'm like, nope. But I built a deck in the back. And so I looked at it and I'm like, can I just build one out of like wood? So I did. I built a rectangular table out of wood, and it's treated wood, and it looks great. And I drilled a big hole in the middle so I could put like an umbrella through it. And I left it through 3 winters, and it's still standing there, and it's great, made out of deck material. Cost me $100 and took me about 4 hours. For a real carpenter, it'd probably take like half an hour, but for me, it took about 4 hours. Okay, so always worth it if you can build your own stuff. So the table is 90 centimeters in length, so let's put 90 centimeters there. And the diagonal of the table is 109 centimeters. I don't know why you would know the diagonal, but okay. That's 109 centimeters that way. Units are the same, that's good. What's the width? Okay, so we'll call that W, and it wants to know what that is. So there's a right triangle. Assuming it's not my table, I doubt mine has right. I already have the long side, so I'm going to be subtracting, right? So W is going to be the square root of 109 squared minus 90 squared. (61.49 centimeters). Yeah. Okay. Number 5, your math teacher says that a right triangle has a hypotenuse of 41 centimeters. Okay, I need to draw it here. I'm already losing track. There's my right angle. The hypotenuse is the longest side, 41 centimeters from there to there. And a side length of 40. So I don't know, let's use 40 there. One of your classmates says that the other side is 9. Is your classmate correct? So they're saying that this is 9, but we're gonna double check that. Okay, so let's call that x. And you're gonna do 41 squared minus 40 squared. And we got 9. So, yes. Classmate is correct. Cool. And hopefully by now you've done enough Pythagorean theorem kind of questions that you feel reasonably confident. How many of you feel pretty confident with those kind of questions? Yeah? If you don't feel confident doing those questions, I could always print you extra practice. Or you can just go on a computer and say, Pythagorean theorem practice, and you'll get websites that give you like thousands of questions, okay? For all math stuff, it's easy to find questions online. Okay, so yesterday, the new skill that we were practicing was labeling a triangle. So very quickly, let's see if we remember this. I'm going to make myself a poorly drawn right triangle. There we go. So let's say that this angle is, doesn't really matter, you can have a symbol there, or it could actually be an angle. Eventually you'll have real numbers there, 40 degrees or whatever. If this is the angle I'm going to be using in my calculator, what's this side called over here? That is the opposite. Yeah, so that would be the opposite from the 40-degree angle. You just write opposite. Then what would this side be called? That's the adjacent. And the longest side, it doesn't matter where the angle is, this side's always called the hypotenuse. Yeah. Okay. And how do you find the hypotenuse? How would you describe where it is? Across from the right angle, the 90-degree angle. Yeah. And it's also the longest side. Okay? So that's what we did yesterday, labeling triangles. You have to be able to do that correctly to be able to move on. Okay? All right. We did some practice with that. Which brings us to what this unit really wants us to learn how to do, which is how to use the trigonometric ratios. How's that for some long words for you? Okay. Now a ratio, in practical terms, a ratio is just a number divided by a number. Okay. Sometimes people will call them formulas or whatever, but they're just ratios. So this is some new language for you to learn for trigonometry. This means the sine of any angle in a right triangle is equal to the length of the opposite side. So for the thing we just drew there, this thing, opposite, okay, divided by the length of the hypotenuse. So what that means is if I know what this number is, and I divide by this number, that will give me the sine of 40 degrees. Which is useful for me later, okay? I know, this is abstract, right? Your brain, what's happening right now is your brain is desperately trying to find some branch in there and trying to attach to it. It's trying to find something that it already knows to make it easier for you. But right now this is abstract, which means your brain is going to be forced to create a brand new stem for trigonometry. Okay? It has nothing to cling to. So that feeling of what the heck are you talking about, okay, that's normal. Try not to panic, because that's also what happens when we don't understand things. We start to panic, right? Okay, this one says that the cosine of an angle is the length of the adjacent side divided by the length of the hypotenuse. So that means the cosine of 40 degrees here, which is just a number, we don't know what it is, but the cosine of 40 degrees would be whatever this length is divided by whatever length this length is. That'll give us the cosine. And the last one, there's only three, is called the tangent. And the tangent of an angle is the opposite divided by the adjacent. So if I took this side and divided by this side, that would give me the tangent of 40 degrees. Okay? In short form, we just say sine theta equals opposite over hypotenuse. You'll see some people will even just put O over H. Okay? I'm also going to show you, so write this into your book here, because it might make it easier for you that struggle with the algebra. I'm going to show you a formula pyramid. It's a little math trick you can use whenever you have like multiplying and dividing. So I'm just going to put S-O-H, and we're going to use that later. S representing the sine, O representing the opposite, H representing the height. So we'll call that a formula pyramid, S-O-H. Okay. I'm going to show you like two ways to do all the problems, and you're going to pick whichever one's easier for you. Some people will like the formulas, pyramids, and some will just use the formulas here. This will allow you to bypass doing algebra. This requires algebra. All right, the next one. What do you think the next pyramid is going to look like? What's going to go here? C. What's going to go on top? A. What's going to go here? H. There you go. And for this last one, what's going to go here? T. O. There you go. There's three formula pyramids to do all our trigonometry work. Okay. And they mention here we often use the acronym. What's an acronym? Have you seen this word before? Yeah, kind of. An acronym is just is like a word where each letter represents an entire word. So really, like scuba. You ever heard of scuba diving, right? Scuba diving means you put on that special mask thing and it helps you breathe, right? Well, scuba is an acronym because it's really, this is scuba. People say I'm going scuba diving, right? Each of these letters stands for a word. Anybody know what scuba stands for? Self-contained underwater breathing apparatus. So that's an acronym. It's really hard to say self-contained underwater breathing apparatus, right? Unless you're a rapper, in which case it's easy for you. So we just use scuba. What's TBH?
That's to be
Oh yeah. So texting language, because nobody wants to write out full words, there's lots of acronyms, right? Like people will do this, right? Laugh out loud. And they'll do it even if they're not laughing out loud, right? Which is weird. Have you done that? Shame on you. Shame on you for putting LOL and lying to the person on the other side of the phone that you're laughing out loud when really you're just maybe kind of smiling, right? Like if someone's using that, they should actually be, in fact, you know they're lying, because if they're able to type LOL, they're not laughing out loud, because it's really hard to type LOL while you're laughing, right? Okay. Any others? You said, what's TBH? What's that? To be honest. Which something that people usually say when they're not being honest. We call that irony, when what you say is the opposite of what you expect. Yeah, to be honest. Okay. Maybe you're on. When you say to be honest, you're probably honest, right? Okay. Can you think of any others people use? Acronyms? Yeah, IDK. Yeah. I don't know, right? Yeah. So we use those a lot to speed up communication. And sometimes you'll see them being used for real things. I think if you watch comic book stuff, Shield, Marvel's Shield. Shield is the large organization that oversees all the superheroes, and nobody watches the Marvel Avengers stuff. You watch that stuff? Okay. I think Shield is, I don't know what it stands for. Okay. Anyway, those are acronyms. So we can often use the acronym SOHCAHTOA. You can say it, right? SOHCAHTOA. SOHCAHTOA. You can make it sound kind of like really important. SOHCAHTOA. To remember the ratios and the order of the sides. Okay. When I was learning this for the first time in high school, I had a teacher that wouldn't let us enter the classroom without saying it. When you got to the door, you had to say, SOHCAHTOA, and then he would let you in. It was a different time. He would also throw erasers, bags of erasers at you if you weren't paying attention. I got hit in the head several times. Okay, now what's the point of this crazy stuff? Okay, the whole point of this is that we can use these ratios to solve, using our calculators, for missing sides and angles. So it's a useful skill, right? And in the real world, I talked about, like, if you want to find out how tall a tree is without actually climbing the tree, right? You can just draw a triangle. You can walk on the ground. You can see how far that is. You can use a little thing to figure out what the angle looking up to the top is. And if you have that, you can use SOHCAHTOA to find out how tall the tree is. And we'll do that. I'll do that exact example later. Okay. Example. Use one of the trigonometric ratios to solve for an unknown side. Okay. To use the trig ratios to solve for an unknown side, the first thing we do is we label the triangle. And we only need to do the sides that have an x or a number attached to them. Okay, we can do that. This is the angle we have to use, right? What's this side called over here? That's the opposite side. And this long side here is the? That's your hypotenuse. Okay. Now if I look over here, what's the trig ratio that has opposite and hypotenuse in it? Only one of them will. This one, right? This is the only one that has O and H in it. Okay, so only the sine theta equals opposite over hypotenuse will work. Okay? You don't have any other options. This is the only one that has opposite and hypotenuse in it. Okay, so then I fill in the information that I know. Okay, we don't have theta, we have the actual angle. What's the actual angle given in the triangle? What's the number that's given to us? 72. So I'm just going to write sine 72 equals, and instead of opposite, we have a letter there. What letter is there? We just have the x, right? Let's put an x there, okay? And lastly, the hypotenuse, we know the length of that. The length is 19. You don't need to put the meters there, 19. Okay, sine 72 equals x over 19. Now we need to solve this. X is being divided by 19, and I'd rather have x by itself. Well, how do I undo division? Multiply. So I could write 19 multiplied by the sine of 72 degrees, and that will give me x. Okay? Now, this is calculator work. First things first, at the top of your calculator, it's hard to see here. Let's get close. Ooh, zoom. All right. At the top of your calculator, you'll see like a little, you should see like DEG for degrees, or maybe it's a D. Okay. What you don't want to see is an R or RAD. If you see R or RAD, that means your calculator is set up to do angles in radians, which look different than degrees. So you should have a button, like mine right here is the DRG button. If I press that, it'll change it. Make sure you're in degrees, DEG. If you're not sure, bring it up to me and I can show you. Okay?
DRG, right?
Yeah. Or DEG or D. You don't want to see R. Okay? It's a different system of measurement. 180 degrees is the same thing as pi radians. So if you're in radians and when you should have 180, it'll say 3.14, which is very confusing. Okay? Everybody get it changed? It's all good? Okay. So then I'm just going to punch in 19 times. And I'm going to do the sine of 72. Now, this is another thing, depending on your calculator. For some of you, you might have to put 72, then hit sine. I'm able to do mine in order, but yours might be backwards. If you have a Texas Instruments, Lanui, I think yours is a Texas Instruments. That's a TI-30A, right? The calculator? Is that a TI calculator?
Oh, yeah.
Yeah. So for you, you're going to punch in 72, then press the button sign. Okay? And yours, yeah, same thing. You're going to have to put 72 and then hit the sign button. Okay? And then I hit equals, and you should get 18.07 is x. If you don't get that, bring your calculator up to me and I'll show you how to punch it in. They're all different, so we have to get used to yours.
See it? I wasted. No, it's fine. It's 19.
19 times sine 72. Yeah, that's good. Okay, so yours you do it. Did everybody get 18?
Yeah.
Yeah. Okay. You had to do yours backwards though, right? 72 sine. Yeah. Did you? Oh, you had, and then hit equals at the end. So yours you do 19 times, then put 72 sine, hit the sine button. No, sine, S-I-N. Good, and then hit equals. There it is. Yeah. So you have to get used to that. Yeah.
So you press twice.
Right. Yeah. Okay, so that's the correct answer, but I'm also going to show you how to do it using the formula pyramid. The formula pyramid allows you to not have to like recognize that x divided by 19 means you got to multiply by 19. Okay? Using the formula pyramid, the way a formula pyramid works, you simply cover the thing you're looking for. So the side we were looking for was the opposite side, right?
Yeah.
So I go to the opposite here and I just scratch it off. What does it mean in math when two things are side by side? Times. So the pyramid, if I scratch off the opposite, it tells me to go sine of the angle times the hypotenuse. This just tells me to go sine 72 times 19. So it skips a step for me, right? So that's the use of a formula pyramid, is it allows you to bypass the algebra. Okay. Okay, moving on. Oh, wait, I want to do my tree problem first, right? How tall trees are. Okay, so I'm just going to move this away, and I'll pull out a small piece of paper because that's all I have handy. My tiny tree problem. Okay. This is you, and you want to know how tall this tree is. Okay? Too tall for you to climb it, plus you don't like climbing trees, you don't know how. Well, there's a wasp nest up there, whatever. You can figure out the angle looking to the top. So let's say you walk away from the tree, okay? So you start at the tree and you use a measuring tape and you go right to the end of the measuring tape. How long are measuring tapes usually? Anybody know? You ever pull one out all the way to the end and break it and have to buy a new one? No. I think usually like 25 meters. Okay. Smaller ones are 25 feet. But let's say this is 25 meters, which means you walk pretty far away from the tree. Okay. And then looking up at it, let's say that the angle is 40 degrees. Okay. Now I can use trigonometry. This is where it's really cool. This is my angle. What's this side called over here? That's the opposite side. Okay? So that's my opposite, OPP. This side here is called the adjacent side. Then I go look at my trig ratios. Which one of these has O and A in it? O and A. Yeah, tangent. Okay, so I can write that trig ratio down. TOA. And what am I trying to find? The A or the O? Well, I know the A, it's 25. I don't know the O, which is the height of the tree. So I scratch that off. Side by side means multiply. So I'm going to do the tan of 40 degrees times 25. Okay. Depending on your calculator, for some of you that might be 40 tan, then 25. But for me, tan 40 times 25, and I get 20.98 meters tall, which is around just over 60 feet tall. Neat. And then if I had a house right here, okay, more of a hut, okay. Would it be smart for me to cut that tree down right at the bottom? Would I be okay? If the tree fell towards the house, would it smash it or not? This is 20.98. This is 25. I'd be okay. Because the tree, this side is not as long as this side. So I could drop the tree, and even if it came straight towards the house, it would, the top of the tree would be around here somewhere. It'd be safe. Okay? So, and if it smashes the house, it means I screwed up the math. Okay? So I'd know if it's okay. But that's a real life kind of useful kind of problem there. And so tree cutting companies can do that if they're worried about where the tree's going to fall and whether it'll clear the houses and stuff. And if it won't, then they'll go up and they'll top it. They'll take some of it off until they know they can safely drop it. Cool. All right. Example 2 here, solve for x. This is the angle I'm using. What's the x side called, regardless of the angle? That's the hypotenuse. Okay. What's this side called? That's the adjacent side. Which one of those formulas has a and h in it? This one, right? So I write the cosine of 55 degrees is the adjacent side, which is 27, over the hypotenuse, which is x. Or I could just write my pyramid down, draw it, and I know that I'm looking for the hypotenuse. In math, when a number's over a number, what do I do? What math operation? Divide. So this tells me to divide. Okay? If I'm doing the algebra here, x is on the bottom here. 27 is being divided by x. I don't want to divide by x, so I can multiply both sides by x. Then x is being multiplied by cos 55. I don't want it there. How can I get rid of something being multiplied? Divide it. So what, in practical terms, what happens is the x switches spots with the cos 55. You end up with x equals 27 over cos 55, which is what the pyramid told me to do anyway. And this, the algebra, is kind of 2 steps, right? You gotta divide, then multiply. So the formula pyramid is actually pretty helpful for those kind of questions. You're less likely to make a mistake. So anyway, I'm going to go 27 divided by the cos of 55, and I get 47.07, I guess that's inches, right? Did you get the same thing when you punched in?
47?
Yeah, 47. Yeah. So, this is the entire unit. It's just a matter of lots of practice and then lots of word problems. And every word problem results in you drawing a right triangle and labeling it and then using this math stuff. So it's a brand new skill, and because it's kind of abstract, if you haven't done this before, you haven't done anything like it in math. So it takes a while for it to sort of sink in and for you to get really good at it. So we got to do lots of practice. Okay? There's not a lot of time left, but you're welcome to start, if you think you're able to start doing this, you're welcome to start doing the practice questions. Otherwise, tomorrow we'll just practice this over and over again. And I got to make sure you get good at it. I mean, it's pretty easy for me just to draw a triangle and make you do it. And we'll get good at it. Okay? So good work. But the steps are always the same. Number 1, label the triangle. Number 2, figure out which one of those things you're using, sine, cos, tan. Then number 3, punch it into your calculator, get the answer. It's a 3-step process.